Welcome students for today's live session. I am going to explain the model question paper related to mechanical properties of solids, mechanical properties of liquids, gravitation and the laws of motion. So these are the today's topics for question paper discussion. Welcome students. Welcome students. For today's live session, I am going to explain question paper for the topics mechanical properties of solids, mechanical properties of fluids, gravitation and laws of motion. So out of these are 4 chapters. So there are so many important questions are there. But in this question paper, I am going to explain some standard models regarding all these topics. Right. First question. A closed rectangular tank is completely filled with water and is accelerated horizontally with an acceleration a towards right. The pressure is maximum at one particular point and pressure is minimum at one particular point according to the given data. So here a rectangular tank is moving with a linear acceleration a is given in the data. So here for this rectangular tank moves with constant acceleration a, I considered 4 points. One is at the topmost point of the tank, one is at bottommost point, and one is at the bottommost point on left side, and one is at the topmost point on left side. Let the width of the tank is L and depth of the water in the tank is small h. Then pressure at point A, pressure at point B, sorry, it is pressure at A, it is D is given, it is C, it is B. So pressure at point D, pressure at point D is 0 almost because it is a closed container, it is not exposed to atmosphere. So there is no horizontal push, there is no vertical downward push at the liquid layer or water layer at point D. So to that pressure at point D is equal to 0. Now pressure at point C, pressure at point C is only due to the vertical downward push. Pressure is due to vertical downward push of these layers of liquid column of length h. So pressure at point C is equal to rho g h. And pressure at point B, pressure at point B is equal to pressure due to this horizontal layers of liquid column of length L. Pressure due to this horizontal layers of liquid column of length at point B and pressure due to this vertical column of liquid length of h. So due to this horizontal layers of liquid column, here it is pressure is rho in horizontal direction acceleration a into L plus pressure due to this vertical column of liquid length h. So rho g h. In vertical direction acceleration is g, in horizontal direction acceleration of this liquid layers is a. So due to that net pressure at point B due to the horizontal movement of this container with an acceleration a, that is constant acceleration a, is rho al plus rho gh. Next, pressure at the topmost point on left side equal to pressure is due to at this point pressure is due to the push of the horizontal liquid layers of length L only, but not the vertically downward push by the upper layers because there is no upper layer of liquid column above A. So due to that only it is due to the pressure due to the horizontal push of this liquid column of length L only at this point. So it is rho A into L along horizontal direction, acceleration is A. So out of all these points, at which point pressure is maximum? So at point B pressure is maximum. At point B pressure is maximum, at point D pressure is minimum. So here answer is pressure is maximum at B, minimum at D. So answer is A. For question number 1 answer is A. So for horizontal container moves with constant horizontal acceleration, then pressure will be maximum at lowest point on left side of this container, and pressure is minimum at the topmost point on right side of the container. So out of all this, these are the equations. So from this question here, answer is A. Pressure is maximum at B, pressure is minimum at D is the answer for question number 1. Next question. If the gravitational force between two identical balls is F, as shown in the figure 1. So gravitational force between these two balls is separated by a distance L is g m1 m2 by r square, that is g m square by, here it is L square. Now what is the force between two balls when arranged as shown in the figure 2? If third ball is arranged like this, having same mass, if it is kept in between these two at certain angular position, then what will be the force between the two initial balls? So the force between any two bodies, any two point objects cannot be intervened by, cannot be affected by the presence of third body. So due to that, force is same even though third body is kept at certain normal distance from the distance separation of these two particles or bodies or two balls. So due to that, answer is F is the answer for question number 2. So what is the force between two balls when arranged in figure 2? So indirectly, what is the force between these two initial balls? That is the question actually, that is the meaning of the question. So even though the presence of this third ball of same mass, here it does not affect the force between the first two balls. So due to that, answer is F. So answer is B for question number 2. This is one of the important point here. So there is no effect of the presence of third body on the force between the two particles separated by certain distance. But there will be force between these two particles. But this force was not affected by the presence of this third body. So due to that, answer is F. What is that F value? G m square by L square is the answer for question number 2. That is equal to F. So answer is B for question number 2. Next question. A tank has hole at its bottom. The time needed to empty the tank from level H1 to H2 will be proportional to. This is the tank filled with water up to certain height H1. Small hole is made at the bottom of the vessel. Then water continuously leaks out to the small hole. Then in t seconds, level drops down from H1 to H2. So this is the final level. This is the initial level of the water or liquid in the beaker. So the time taken by the level of the water in the beaker drops down from level H1 to H2 in a cylindrical container when small hole is made at its lowermost bottom position. Is T is equal to, all of you know the basic equation, square root of 2 by G into A by small a into root of H1 minus root of H2. This is the equation for the time taken by this water leaks through small hole made at the bottom of the cylindrical vessel, that is from height H1 to H2 is root of 2 by G into A by capital A by small a into root H1 minus root H2, where capital A is the area of cross section of this cylindrical vessel, small a is the area of cross section of the hole made at the bottom of the cylindrical vessel. So this time taken is directly proportional to square root of H1 minus square root of H2. So the time taken to drop down water level or liquid level from height H1 to H2 when it leaks through a small hole made at the bottom of the cylindrical vessel filled with certain liquid. So T directly proportional to root of H1 minus root of H2 is the answer for question number 3. So it is one of the standard formula have to kept in mind. Okay, right. For JEE advanced level, on the basis of this formula we go for further calculations. Instead of cylindrical vessel, we considered spherical vessel. A small hole is made at the bottom. So what is the time taken by the level drops down from middle level to completely empty down all the vessel. So time taken is different for different shape of the vessels, but this formula is only applicable for when small hole is made at the bottom of the cylindrical vessel. Okay, you have to remember the standard form. At the same time, you have to remember the derivation of this equation also. Okay, right. Next question. 64 spherical raindrops of equal size are falling vertically through air with a terminal velocity 1.5 meter per second. If these drops coalesce to form a big spherical drop, then terminal velocity of the big drop is. So 64 here spherical raindrops. Each drop falls with a terminal velocity 1.5 meter per second. So radius of the each drop is supposed to be r. If we all these droplets coalesce to form a big drop of radius r, then we know the radius of this big drop is r equal to n to the power 1 by 3 into small r. So when big drop coalesces into when number of droplets coalesce into a big drop, then radius of the big drop is r equal to n to the power 1 by 3 into small r. So terminal velocity, all of you know the basic formula for terminal velocity of any falling body through a viscous medium is Vt equal to 2 by 9 r square g into rho minus sigma by eta, where rho is the density of the falling body, sigma is the density of the medium at which body is falling, and eta is the coefficient of viscosity of the medium, r is the radius of the falling sphere in the viscous medium. So here this terminal velocity is directly proportional to r square. So for single droplet, the terminal velocity is 1.5 meter per second. If these 64 droplets coalesce to form into a single drop, then what will be its terminal velocity? So what is the radius here? 64 whole to the power 1 by 3 into r. 64 can be written as 8 square whole to the power 1 by 3. 8 again written as 2 cubed whole to the power 2 by 3, that equal to 4. So therefore V directly proportional to r square means V1 by V2 equal to r square by capital R square. V1 value is given as 1.5 by V2 is equal to r square by here this value is n to the power 2 by 3 into r whole square. So n to the power 2 by 3 r square. So r square gets cancelled. From this we get V2 is equal to, it is 4 into, here it is, so this value is given as 1.8. So therefore it is 3 gets cancelled. So it is 16, it is 8 cubed, it is 16 is there. So from this we get 16, this value. So therefore it is V2 is equal to, here 16 into 1.5, 24 meter per second is the answer for question number 4. So do the calculation here. So n to the power 1 by 3 into r it is. So 8 square whole to the power 1 by 3 into r. So from this here we get n to the power 2 by 3. N to the power 2 by 3 into r square. It is only n to the power 1 by 3. So from this we get 4 is there correctly. So 4 square we get. So 16 into 1.5. From this V2 is equal to 24 meter per second is the answer for question number 4. So for this one capital R equal to 4 centimeter, okay. 4 into this radius, but we don't know the radius, 4r it is. So you substitute this one as 4r, 1 by 16 it will be, then for V2 equal to 16 into 1.5, that will be 24 meter per second is the answer for question number 4. So here we have to remember, when number of droplets coalesce to form a single drop, the volume of merging of all these droplets into a single drop is same. So mass of the all droplets is same. That is for mass of the drop is equal to total mass of the all droplets. So here we consider law of conservation of mass. On the basis of law of conservation of mass, here volume is constant before and after merging. On that basis we derived this equation as radius of the big drop when number of identical droplets coalesce to form a single drop, then radius of the big drop is n to the power 1 by 3 into small r. So terminal velocity V directly proportional to r square. From this V1 by V2 equal to small r square by capital R square. The small r is radius of the droplet, capital R is the radius of the drop after merging of all these droplets into a single drop. So for question number 4, answer is C, 24 meter per second. Question number 5. Two planets A and B have radius in the ratio 1:6. A satellite revolving nearer to the surface of the planets have same time period of revolution. The ratio of the density of the planets A and B is. So all of you know that when satellite revolves around a planet, for this one the time period of revolution is equal to 2 pi into square root of r cubed by gm, when it revolves very close to the surface of the earth. Suppose if this satellite revolves at certain height, then time period is written by 2 pi root of r plus h whole cubed by gm. But in this case here, that for two planets the ratio of their densities is given, that we have to calculate. So in terms of density you have to convert this equation. T equal to 2 pi root of r plus h whole cubed by g into mass of the planet is 4 by 3 pi r cubed into density. So time period is inversely proportional to square root of the density of the planet. So around two planets there are two satellites are revolving in the two different radii in the ratio 1:6. But according to given data, for these two satellites both revolves with same time period. So both revolves with same time period means t is same. So time period here is independent of, when it is converted into radius, this r cubed gets cancelled. So this term gets cancelled. So time period is independent of this density of the planet. So therefore what we want, density of rho 1 is to rho 2 is equal to 1:1, because time periods are same according to given data. So answer is, the ratio of the density of the two planets is 1:1 is the answer for question number 5. So answer is C. So here two planets revolves near to the surface. So this r cubed and r cubed gets cancelled. Near to the surface, this is the formula. So r cubed gets cancelled. Only time period depends only on density of the respective planet. If it revolves at certain height, then only it depends on this height radius. But it revolves very close to the surface of the planet, then this r cubed and r cubed gets cancelled. We get t is inversely proportional to root of rho, density of the respected planet. So here in this case, for two satellites around the two respective planets, time periods are same. So due to that their densities are also equal according to given data. So answer is C for question number 5. Next question. Question number 6. A rectangular tank is filled completely with water. A hole at its bottom is unplugged. The graph between the velocity of the flux versus depth of the water from the top of the tank. So this is the tank. According to given data, see the diagram. According to given data, here from free surface the depth of the water is h. Initially this is the depth up to which water is filled. When small hole is made at bottom, when it is unplugged here, then with respect to the free surface, this will be the drop down level of the water in the tanker. Okay. So here this becomes, suppose initially it is h, after some time the level supposed to be small h according to given data. So small h is represented from free surface to the level. So here, but we want, this is the at the time of your observation, this is the height of the level of water, height of the water with respect to the small hole made at its bottom. So this is h minus h. So velocity of efflux V equal to square root of here it is root of 2gh. So root of 2g into, in place of h I write h minus small h. So as water leaks out continuously, what happens? H increases. As water leaks out continuously, h increases. So h increases means h minus h value decreases. Due to that, velocity of the flux decreases non-linearly. So here, if h increases, h minus h decreases non-linearly. So due to that, velocity of the flux also decreases non-linearly. So velocity varies in accordance with this value of height h. So the initial level of the liquid is supposed to be at height h. At the time of your observation, after some liquid passes through the small hole, let from initial level to this level of the liquid is h, then the level of the surface of the liquid to the small hole is h minus h. So velocity of efflux of the liquid through the small hole is v equal to root of 2g into h minus h. So as this level increases, means indirectly h minus h value decreases. So h minus h value decreases means indirectly here velocity of efflux decreases. So according to the given option, see the graph here. So B is wrong because it increases. C is wrong. C is because it is linear relation is given, but it decreases non-linearly. So C is wrong, B is wrong, but it increases linearly, it is wrong. So answer is, so it decreases non-linearly. So answer is as height increases, this height. So not height, this depth increases from free surface of the liquid at its initial position. As depth increases from initial position of the free surface of the liquid, then velocity of efflux also decreases. So for question number 6, answer is A. So it is another standard important small logic oriented question. Okay, right. For 6th one, answer is A. Question number 7. A cubical block of mass capital M is kept inside the liquid of variable density rho equal to rho y is equal to rho naught into 1 plus by, where y is the distance from free surface of the liquid. Initially 1/4 of the cubical block is immersed. Then what is the mass m dash of the additional block kept on the first block to immerse it just completely? So in this case, for this liquid, it is not the liquid of uniform density. As we go deep into the liquid, its density varies in accordance with the depth. So suppose at this point, what is the density? At this point here, at a depth y, at a depth small y or dy, here it is density is equal to, at a depth small y, density rho y is equal to, here it is rho naught into 1 plus by at a depth small y density. Now according to given data, initially when block is there, when it floats on surface of the liquid of this variable density, initially see the data, initially 1/4 of the cubical block is immersed. So this length of the block is L by 4. The length of the block is L by 4 and mass is m. So what are the forces acting on the block here? One is weight of the block is balanced by buoyant force. So what is the buoyant force here? Buoyant force is equal to volume into density into g. So volume is, because when we go into small depth dy, then the variation of density is known by using this relation. So due to that, if we go into small depth here dy, the area of cross section of this block is supposed to be A, then it is dV into density into g. That will be the buoyant force on the small elemental liquid strip. So what is the total buoyant force in between this L by 4th portion of the block of length L? So here, as we move from this point to this point here, as we move from the surface of the liquid to 1/4 of the length of this block here, there is a variation of density of the liquid is there. So due to that, here I considered for one small elemental strip of this liquid is considered, which exerts buoyant force dB. So for this total length, buoyant force can be obtained by integrating of this buoyant force due to this elemental strip within the limits 0 to L by 4. 0 to L by 4, that equal to integral of 0 to L by 4 into what is dV, area of cross section, into dy into density of this liquid is rho naught into 1 plus by into g. So this is the balanced equation when only we considered the one block of mass m immerses in a liquid such that 1/4 of its length is inside of the liquid. At that time, the weight of this block was balanced by buoyant force. So that buoyant force is variable because the liquid is having variable density. So I consider one of the small elemental strip of thickness dy. On this thickness, due to this thickness of this elemental strip, it exerts buoyant force d into by. So in order to have effective buoyant force on this elemental strip of length L by 4 regarding this block, then buoyant force can be obtained by integrating that buoyant force equation for this elemental strip within the limit 0 to L by 4. Okay. So from this we get here mg is equal to here from this A into rho naught into g is constant, the remaining terms are variables. Integral of it is 1 plus by into dy within the limit 0 to L by 4. 0 to L by 4. So from this g gets cancelled, m equal to a into rho naught into integration of 1 into dy, it is y, plus here for b into y it is b into y square by 2 within the limit 0 to L by 4. So that equal to a into rho naught into for y. By substituting the upper limit we get L by 4 plus b into or y square, b by 2 is there, L by 4 whole square, that is L square by 16. So from this we get mass of the block is a into rho naught into L by 4 plus b L square by 32. First I calculated mass of the block. Now according to given data, now what is the mass m dash of the additional block kept on the first block to immerse it just completely? So when additional block of mass m dash is kept over it, then this first block was completely immersed inside of the liquid. At that time here the additional weight m dash g is equal to the buoyant force exerted by liquid on the additional length of the block which goes into the liquid. So by keeping up this block on surface of this block of mass m, the weight of the additional weight m dash g is balanced by the buoyant force by the liquid on the remaining portion of the length of the block only. So due to that here m dash g is balanced by buoyant force due to buoyant force by the liquid on the remaining length of the initial block. So what that length here L by 4 to L. According to given data, see the data here. What is the mass of the additional block, so that the first block to immerse it just completely. So due to that, in between L by 4 to L, the additional buoyant force exerted by this liquid is equal to the additional weight placed over the first block, that is m dash g is equal to integral of dfb. So therefore it is integral of a into dy into rho naught into 1 plus by, rho naught into 1 plus by, a into dy rho naught into 1 plus by into g within the limits L by 4 to L. So from this m dash g is equal to a into rho naught into g into integral of 1 plus by into dy within the limits L by 4 to L. So m dash is equal to a into rho naught into for L 1 into dy integration is y. So y plus b into y square by 2 within the limits L by 4 to L. So from this we get a into rho naught into L minus L by 4 plus b by 2 into, by applying upper limit it is L square minus by applying lower limit it is L square by 16. That equal to a into rho naught into 3L by 4 plus b by 2 into 16 L square minus L square, 15 L square by 16. So that means m dash is equal to a rho naught into 3L by 4 plus 15b L square by 32. It is equation 2. So, from equation 1, what is m value? M value equal to a rho naught into L by 4 plus b L square by 16. B L square by, see the B L square by 32 is the m value. So, what we want here, see the options, m dash term in terms of m. So, by dividing equation 2 with 1, by dividing 2 with 1, we get m dash by m is equal to some term. See the options here, m dash by m equal to, we get here it is 3L by 4 plus 15b L square by 32 by L by 4 plus, it is L by 4 plus, it is b square by 32 only. So, this is the term. So, in all options there is no such term. So, due to that, here answer is D, none of the above. So, m dash by m equal to 3L by 4 plus 15b square by 32 by, here it is L by 4 plus b square by 32. So, what I did here, first I calculated mass of this block by considering buoyant force within the limit 0 to L by 4. Then afterwards, so if additional block is kept to our first one, in order to sink the first block completely, then again I calculated, I consider the same equation for buoyant force, but limits of integration is changed from L by 4 to 0 to L by 4, here L by 4 to L. So, within the limits I calculate once again, the mass of the additional block kept to our first one is, it is a rho naught into 3L by 4 plus 15bl square by 32. So, by dividing 2 with 1, we get m dash by m is like this. So, by observing all options here, no option is matched with this value. So, answer is none of the above, but the procedure for calculation of mass of the additional block and mass of the block is most important. So, this is one of the standard model question regarding mechanical properties of fluids regarding JEE mains and JEE advanced level examination. Okay. So, standard model question it is. Try to follow this one. Okay. Next question. Calculate the energy needed for moving a mass 4 kg from the center of the earth to its surface. If radius of the earth is 6400 km and acceleration due to gravity at the surface of the earth is, so from center of the earth to surface, a mass is moved from center of the earth to surface. So, here what we want here, the energy needed for moving of a mass of 4 kg. So, m equal to 4 kg. So, when it is moved from center of the earth to surface here, so work done, what is the work done in moving this one? Work done equal to negative value of change in potential energy, because here mass is moved from center of the earth to surface against the conservative force, that is gravitational force. So, work done by any conservative force is equal to negative value of change in its potential energy. Therefore, W equal to minus of du. Therefore, minus of du is uf minus ui, that equal to ui minus uf. What is the potential energy of the mass? Potential energy can be written as gravitational potential at center into mass minus, we know that final potential energy on surface of the earth it is minus gmm by r, already negative sign is taken. So, that is gmm by r. Okay. So, at center it is, what is the gravitational potential at center? Gravitational potential at center is 3 by 2 gm by r is there, but already negative sign is taken. So, 3 by 2 gm by r. So, 3 by 2 gm by r it is, minus of minus, minus is there. So, it is minus of 3 by 2 gm by r into mass, minus of minus it is plus gmm by r. So, from this we get gmm by minus gmm by r, gmm by 2r it is, but gm by r is gr. What is gm by capital R? Gr, that equal to minus m gr by 2. So, what is the work done to move a block of mass m from center of the earth to surface is minus mgr by 2, but energy needed is positive value of that one. So, So energy needed is equal to mgr by 2 is the energy needed to move this block from center of the earth to surface. So what are the values of mass g and r? So energy needed is equal to mass is 4 kilogram, g is 10 into r value is 6400 kilometers by 2. So after calculation we get 1.28 into 10 to the power 8 joules. So what is the energy needed? Energy needed to move a block of mass m from center of the earth to surface. In what way I calculated potential energy of this mass at center of the earth? So potential energy of the block at center of the earth is written as gravitational potential at center of the earth multiplied by mass. So what is the gravitational potential of any body at center of the earth? That is minus gm by minus 3 gm by 2r or minus 3 by 2 gm by r. On surface of the earth its potential energy is minus gmm by r. So here it is minus of 3 by 2 gmm by r, minus of minus it will be plus gmm by r. So after calculation we get minus gmm by 2 into capital R, but we know that gm by capital R is small g into r. So this is the amount of work done in moving the body from center of the earth to surface against the gravitational force. This negative sign represents work done against the gravitational force, but energy needed to move this one will be taken as positive. So therefore mgr by 2, m is 4, g 10, r value 6410 cubed by 2. From that after calculation we get 1.28 into 10 to the power 8 joules is the answer for question number 8. So it is also another standard formula I have to remember, that is gravitational potential of the body at the center of the earth is minus 3 by 2 gm by r. What is the gravitational potential of the body on surface of the earth? Minus gm by r only. It is minus 3 by 2 gm by r, on surface it is minus gm by r. On that basis potential energy on surface is minus gmm by r, and gravitational potential energy at center of the earth for a body is minus 3 by 2 gmm by r. So that point you have to kept in mind. This is the important formula I have to kept in mind. Next question. So answer for this one is A. 1.28 into 10 to the power 8 joules is the answer for question number 8. Next one. A steel rod is projected out of a rigid wall. The shearing strength of the steel is 345 mega Newton per meter square. The dimensions AB equal to 5 centimeter, BC and BE equal to 2 centimeter. The maximum load that can be put on the face ABCD is. So maximum load. So this is the wall. For this wall, a steel rod is projected out of the wall. This is the rod here. ABCD is the one of the face of the rod. It is projected out of the wall. This is wall. Okay. Here in this case, here it is ABCD is the face of the here it is steel rod. So it is the upper face of the steel rod. So now what is the maximum load that it can be put on face ABCD? So this is the maximum load. We know that here it is the load acts in vertically downward direction. This is the load, that is force, maximum load. So due to this maximum load, it may undergo shearing strain. It may undergo shearing strain due to this maximum load. So this length is 2 centimeters given, this length is 2 centimeters given. So force is to be applied tangentially to the surface of area 2 centimeter into 2 centimeter. So area of effective area at which the force tangentially applied on this one is equal to, it is 2 into 2 into 10 power minus 4, that is 4 into 10 power minus 4 centimeter square is the area. Now what is given the data? The shearing strength of the steel is given. Shearing strength is nothing but breaking strength of the steel is given. Breaking strength is equal to 345 mega Newton per meter square. So it is M represents mega into 10 power 6 Newton per meter square. So breaking stress is written as breaking force by. Breaking force is nothing but maximum load that it can bear by area of cross section at which the force or load is applied tangentially to the surface. So in this case, this is the force. So this is the force action vertically downward direction. So area to be taken tangential to the direction of the application of the force. So this is the area. This is the area at which I have to consider. So therefore, braking force is equal to braking stress into area of cross section at which this force or load is to be applied. So therefore, braking stress is given as 345 into 10 to the power 6 into area of cross section 4 into 10 to the power minus 4. 4 into 10 to the power minus 4 it is. So after calculation, your braking force is mg. We want the maximum load in terms of kilogram we want. So m equal to 345 into 10 power 6 into 4 into 10 power minus 4 by g value is 10. Then you do calculation. After calculation, you get 1380. After calculation, you get the answer is, I will check that answer. Answer is 13,800 kg. 13,800 kg is the answer for question number 9. So answer is C for question number 9. So what is the question here? The maximum load that it can be put on the face A, B, C, D. Indirectly, its weight acts vertically downwards. So you have to consider the area of cross section at which it is tangential to the direction of the application of the force. So this is the area. So in this case, along this area only the force in the form of load is to be applied, but it can bear the maximum strength. It can bear the maximum strength as 345 mega Newton per meter square. So braking strength of that given steel rod is 345 into 10 power 6 Newton per meter square. Okay. So from this, braking force is represented as mg. So mg is equal to 345 into 10 power 6 into 4 into 10 to the power minus 4 divided by g value. That will give the maximum load that it can bear in terms of kilogram. After calculation, here we get 13,800 kg is the answer for question number 9. Next question. In a cylindrical container open to the atmosphere from top of the liquid filled up to 10 meter depth, the density of the liquid varies with the depth from surface as rho h is equal to 100 plus 6h square, 100 plus 6x square, where h is in meters, rho is in density, in kg per meter cube. The pressure at the bottom of the container will be, this is the container, at the bottom of the container, what is the pressure? So we know that at bottom pressure is due to atmosphere, pressure due to these layers of liquid column. So pressure at bottom is equal to P naught plus, this is rho g h. But according to given data, for this liquid also having variable density. So due to that, here we have to consider this h value in terms of dh. So rho g into, in place of dh, rho g into dh within the limits 0 to h. So this is the pressure at the bottom of the liquid of variable density is given. I consider small elemental strip of length dh. Then what is the pressure exerted by this elemental liquid column of length dh at point B, that is rho g into dh, where rho is the density. Therefore, P naught plus integral of 0 to, what is the depth here? 10 meter is the depth, 0 to 10 into rho value is given as 100 plus 6h square into g into dh. So P naught value, P equal to, P naught value is 10 power 5 plus integral of 0, 100 plus 6h square, integral of 0 to 10 into dh into g. So after calculation, we get answer as, do the calculation. After calculation, we get answer as 1.3 into 10 power 5 Pascal is the answer for this question. So what is the integration of 100 plus 6h square? So 100 into h plus, for 6h square integration, 6 into h cubed by 3. You substitute h value as 10. then you get one value by adding this value to 10 power 5. See the options here. So here 1.3. So you get only it is in the order of 10 cubed or 10 cubed or something. So from this, after addition of this term to 10 power 5, then we get 1.3 into 10 power 5 Pascal is the answer for question number 10. Just like in the previous problem, here also the variable density of the liquid is given. Then what is the pressure at bottom of the liquid of variable density? So pressure due to atmosphere is P naught plus pressure due to this liquid column of length 10 meters is given. So I consider small elementary strip of length at dH, then pressure due to that elementary strip is rho g into dH. But here pressure due to this column of length h can be obtained by integrating this rho g into dH within the limits 0 to h, that is 10 meter here. So after calculation we get 1.3 into 10 power 5 Pascal is the pressure at the bottom of the vessel containing liquid of variable density, that is given as rho equal to 100 plus 6h square is the answer for question number 10. Here do the calculation here. After calculation we get 1.3 into 10 power 5 Pascal is the answer. Next question. A liquid is kept in a cylindrical vessel. When vessel is rotated about its axis, the liquid rises at its sides. If the radius of the vessel is 0.05 meter and the speed of the rotation is 2 revolutions per second. So speed of the rotation is given. Speed of the rotation means indirectly it is 2 revolutions per second. Indirectly frequency of revolution is given as 2. Frequency of revolution is nothing but 2 revolutions per second. Number of revolutions per second is called as frequency of revolution. What is the difference in the heights of the liquid at the center and at the sides of the vessel? So for this vessel, when this vessel is under rotation with constant angular velocity omega, all of you know that liquid depresses at center and rises along the edge of the vessel. Liquid depresses at center and rises along the edge of the vessel to a height h. So what is the kinetic energy per unit volume? Kinetic energy per unit volume. Kinetic energy per unit volume of the liquid at center of rotation is equal to potential energy per unit volume when it rises to a height h along the walls of the rotating vessel, that equal to potential energy per unit volume. So what is the kinetic energy per unit volume of this rotating liquid in the vessel? Here it is half rho v square is equal to potential energy per unit volume is rho gh. So that is rho gets cancelled, half into rho. So what is the velocity at this edge? Velocity of the liquid at the edge is v equal to r omega. So r omega whole square equal to gh. So from this what we want? What is the height raised by this one? What is the height raised by this one? Due to rotation of this vessel. So h is equal to r square omega square by 2g. This is the height at which the liquid rises along the sides of the vessel with respect to center of rotation of the liquid in a rotating vessel. So when vessel is under rotation along with the liquid with constant angular velocity omega, or frequency of rotation is given as 2 revolutions per second, then up to what height the liquid rises along the walls of the container. So by consider simple point here. So in so many books it will be different. So here I consider simple point. So for this liquid, all of you know total energy remains same. With respect to this level, potential energy per unit volume is 0. With respect to this level, at this point there will be some potential energy per unit volume, but kinetic energy is almost all minimum. So due to that, here the maximum value of velocity or speed of the rotating liquid is written as here r omega, because it is under perfect rotation with constant angular velocity omega. Due to that, here v is replaced by r omega, rho gets cancelled. From this, h is given as r square omega square by 2z is the final equation. So from this you substitute the given data. What is the r value here? Radius is 0.05 whole square into omega, frequency, what is omega? 2 pi f. So 2 pi f, it is 4 into pi square into omega square, that is 4 by 2 into g10. According to given data, pi square value is taken as 10. So pi square gets cancelled. So from this it is 16. 16 by 2, 8. 8 is, that is 2 centimeters. 2 into 10 power minus 2 meters, that equal to 2 centimeter is the answer for question number 11. So, this is the another standard formula you have to remember. When liquid in a vessel under rotation with constant angular velocity omega, the level of the liquid rises along the walls of the container with respect to the center of rotation of the liquid is r square omega square by 2z. On that basis also the extension of the problems will be given. Okay, right. For question number 11, answer is A. Question number 12. A solid sphere of radius r is floating at the interface of the two immiscible liquids of densities rho 1 and rho 2, where rho t is more than rho 1. Half of its volume lying each. The height of the upper liquid column from the interface of the two liquids is small h. The force exerted on the sphere by upper liquid. Force exerted on the sphere by upper liquid is that we want. So, this is only this half hemisphere of this sphere is under the effect of the upper liquid. So, only the force exerted by liquid on the upper half of the solid sphere only. So, now this is filled up to height h for liquid h of density rho 1. Now, tell me what are the forces acting on the upper half of the solid sphere here. It is pressure due to this h layers of liquid is rho g h and pressure is P naught. Pressure is P naught, and at this flat surface of the imagined hemisphere, the pressure is, what is the pressure here? It is, so at this point here pressure is P naught plus, at this point here you have to imagine at this point this is the liquid. So, it is pi r square. Pi r square is the area of cross section. Here you have to consider the force, upward force, pressure into this area of cross section. So, the resultant of this downward and upward force, that will give buoyant force on this one. The resultant of these two will give buoyant force on this one. So, buoyant force is equal to downward force P naught plus rho g h into area of cross section. P naught plus rho g h into this area of cross section is, it is pi r square minus this pressure, this upward force on the flat face of the hemisphere is F equal to P into area of cross section, P into area of cross section. So, from this what we want here? What we want? The pressure by upper surface here, pressure by the force exerted on the sphere by the upper liquid, on the upper liquid. First, we have to calculate force exerted by liquid on this one. So, this will be equal to, this is F1, all this one, F1. So, here FB is equal to F1 minus F2, F1 minus F2. So, I want F1. So, F1 is equal to buoyant force plus F2, buoyant force plus F2. So, first I consider this one as F1, okay. This one as F2. So, all this one as F1 and this one as F2. So, resultant of this downward and upward force, that will give buoyant force. So, from this what we want? Force by the upper liquid on spherical part of the solid sphere, that we want. So, Fb plus F2. So, F1 is equal to, what is Fb here? Buoyant force is equal to, on this part here, buoyant force is equal to, buoyant force is 2 by 3 volume V rho g, 2 by 3 pi r cubed into density, and this one buoyant force is density rho 1 into g plus F2 value, this F2 value on this flat surface, this force will be, this is the force here, P naught plus rho GH, rho 1 GH into area of cross section pi r square. So, from this is the force here. So, F1 is equal to Therefore, F1 is equal to P naught plus 2 by 3 pi r cubed plus P naught into pi r square. So, P naught into pi r square, P naught into pi r square plus 2 by 3 pi r cubed. 2 by 3 pi r cubed is, you take pi r square, rho 1 is g is taken as common factor, pi r square rho 1 g is taken as common factor into, here it is, what is h here? Volume is there, h is there, h minus 2 by 3, h minus 2 by 3 r. So, this is the equation. So, in this case here, downward force is F1, upward force is F2. So, upward force is F2. Difference of these two will be buoyant force. So, I consider it is minus B here, it is minus B. So, buoyant force is minus B here. So, due to that I put minus. So, for that reason F1 equal to P rho naught into pi r square into pi r1 square rho 1 g into h minus 2 by 3 r. Why I considered here minus Fb? I consider resultant of this downward and upward force is buoyant force is actually, buoyant force always acts in upward direction. So, F1 minus F2, that equal to minus of that buoyant force, because resultant will be F1 minus F2 is written as here a buoyant force, but it is in downward direction I considered. Actually buoyant force in upward direction, due to that I put minus. Or you can write buoyant force is equal to F2 minus F1. Buoyant force is equal to F2 minus F1. So, F2 minus F1, that will give buoyant force. So, I corrected this one as minus Fb equal to F1 minus F2. So, from this F1 equal to minus Fb plus F2. So, that is minus of 2 by 3, minus of 2 by 3 into pi r cube rho 1 g plus P naught plus rho 1 gh into pi r square. So, from this F1 equal to rho naught pi r square plus of pi r square rho 1 g into h minus 2 by 3 r is the answer for this question. So, answer is A. So, once again, so on this solid sphere, here the what we want here, the force exerted on the sphere by upper liquid. So, here this sphere, this half of this sphere will experiences upward force as F2, downward force as F1. The resultant of these two will give buoyant force Fb in upward direction. Here I have written F1 minus F2 as minus Fb. So, I want Fb. So, that is this F2 minus Fb, that will give buoyant force here. So, due to that here F1 is equal to minus Fb plus F2. So, therefore, it is minus 2 by 3 pi r cubed rho 1 g plus here F2 is, for this one F2 is P naught plus rho g h into area of cross section is pi r square. So, from that after calculation we get force by this upper liquid on this sphere is P naught into pi r square plus pi r square rho 1 g into h minus 2 by 3 r is the answer for question number 12. So, here I considered F1 minus F2 as minus Fb, or Fb is equal to F2 minus F1, that is the correct relation, because buoyant force is the net upward force acts on the body is the resultant of this upward thrust and downward thrust by this upper liquid, but net force will be always in upward direction, that is buoyant force, always buoyant force acts in vertically upward direction. So, due to that here I considered minus Fb equal to F1 minus F2, that is Fb equal to F2 minus F1. On that basis I put minus here. So, after calculation we get F1 as P naught into pi r square plus pi r square rho 1 g into h minus 2 by 3 r is the answer for question number 12. Answer is A. Question number 13. A light balloon filled with helium of density rho helium is tied to a light string of length L. The string is tied to the ground forming an inverted simple pendulum. If the balloon is displaced slightly from equilibrium as in figure and released, the time period of the motion is. So, this is the balloon. Tied balloon here acts as an inverted pendulum. It is filled with helium. This is the length of the balloon pendulum is L. So when it is slightly displaced, when it is slightly displaced from its equilibrium position through small angle, then what are the forces are acting on the helium filled balloon? One is here weight of the helium acts vertically downward direction. Weight of the helium acts vertically downward direction. At the same time, the buoyant force by air layers, buoyant force due to air acts in vertically upward direction. So net force on this one is here Fb minus mg. Net force on this one is Fb minus mg. So that will give net force, but the net force acts at certain perpendicular distance with the point of connection here, point of contact here. So net force doesn't act at a line passing through the center of this connection. So it acts at a perpendicular distance from a line passing through this point of connection. So due to that, here we have to consider torque acts on the balloon. So when it is slightly displaced from its equilibrium position, then it executes angular simple harmonic motion about this position, about this point of contact. So due to that, for angular simple harmonic motion, we have to consider restoring torque acts on the oscillating body. So what is the restoring torque acts on it? So restoring torque acts on it is equal to minus of net force into perpendicular distance. So net force, what is net force here? Restoring torque is equal to net force is buoyant force minus weight of the helium into perpendicular distance. Here it is L. Approximately it is, what is perpendicular distance here? This is the perpendicular distance x. So that x is equal to, this arc length is x. Arc length equal to radius into angle. So perpendicular distance is x is equal to L into theta. So that is restoring torque is equal to minus of buoyant force. What is buoyant force here? Buoyant force due to air layers only. So volume of the balloon into density of the air into G minus weight of the helium. Volume of the helium into density of the helium into G weight into L into theta is equal to restoring torque. Due to this, it oscillates simple harmonically. So due to that, this moment of inertia is I about this point into angular acceleration is alpha. So alpha is equal to minus of Vg into density of air minus density of the helium into L into theta by moment of inertia of the oscillating balloon. Indirectly, it is nothing but some mass is oscillating at a perpendicular distance L. So moment of inertia is ml square, m into L square. Therefore it is minus of Vg into density of the air minus density of the helium into L into theta by, in place of mass of the helium, it is volume into density of the helium into L square. Okay. So here L gets cancelled. So from this, alpha is equal to minus of Vv gets cancelled, L gets cancelled, alpha equal to minus of density of the air minus density of the helium by density of the helium into here it is G by L into theta. Now it is compared with the standard form of angular simple harmonic motion form, alpha equal to minus omega square theta. So from this omega square is equal to, what is the basic equation for omega square here? Omega square equal to density of air minus density of the helium by density of the helium into G by L. So omega square is density of the air minus density of the helium by density of the helium into, it is G by L. So omega is equal to like this. Omega can be written as 2 pi by T. So from this, what the time period of the oscillation of this helium filled balloon connected to a point like this. So T equal to 2 pi into root of L by G into density of the helium by density of the air minus density of the helium. So that is the time period of oscillation of the balloon in this case. See the options here. So 2 pi into root of density of the helium by density of the air minus density of the helium into L by G is the answer for question number 13. So it is another standard model question. So what I considered here, when balloon is tied like this, when it is slightly displaced from its equilibrium position, then what are the forces acting on the displaced balloon? One is weight of the helium acts vertically downward, buoyant force due to air layers acts in vertically upward direction. So your net force will be in upward direction, that is buoyant force minus weight of the helium in the field in the balloon. But it undergoes angular simple harmonic motion. So restoring torque acts on the oscillating balloon is equal to net force multiplied by perpendicular distance. What is the perpendicular distance here? This is the net force in upward direction. Perpendicular distance with respect to this center of oscillation is x. So x is replaced by arc length equal to this radius of rotation, radius of oscillation into the angular displacement theta. Therefore x equal to L into theta. So from this we get here x value as L into theta and B value as volume into density of the air. Buoyant force is due to air layers but not due to helium. Therefore density of the air into G minus weight of the helium is volume into density of the helium. Volume into density is mass into G value into L theta equal to I alpha. Here moment of inertia of the helium filled balloon is simply it is the mass oscillates at a perpendicular distance L from x of rotation. Due to that here x of oscillation also here, that is m L square, where m is the mass of the helium. Mass of the helium is replaced by volume into density of the helium into L square. One L gets cancelled, and after calculation we get alpha value as minus of density of air minus density of helium by density of helium into G by L into theta. Now it is in the form of standard form of particle executing angular simple harmonic motion. Now it is compared with standard form of particle executing angular simple harmonic motion is alpha equal to minus omega squared theta. So from this omega square value is, here it is a density of air minus density of the helium by density of the helium into G by L. From this I calculated angular velocity and it is equated to 2 pi by T. Then the time period of oscillation of the helium filled balloon is calculated as 2 pi into root of L by G into density of helium by density of the air minus density of the helium. That is the final answer for period of oscillation of the helium filled balloon. So answer is D for question number, here it is 13. So this is another standard model question for JEE mains and JEE advanced level examinations. So you have to compulsory focus on such type of model questions. Next question. A plastic circular disc is placed on a thin oil film spread over a flat horizontal surface. The torque required to spin the disc about its central vertical axis with constant angular velocity is proportional to. So a plastic circular disc is there. A plastic circular disc is placed on a thin oil film. Thin oil film is there. This is the oil film. This is the radius of the disc. Spread over the flat horizontal surface. The torque required to spin. Torque required to spin means here. So when this plastic circular disc is placed on oil film, then torque required to spin means here. So this frictional force will be different at different layers of the liquid in contact with the plastic surface. So in order to spin this plastic circular disc over the thin film, thin oily layer, then this frictional force will be different from center of rotation to edge of the circular disc. So it is different at different radial distances. So there is a variable frictional force exists between the oily film and surface of the plastic circular disc. For that reason, here I considered number of thin layers of liquid film of thickness dr and radius r, and this force is, here it is, frictional force is F, it is df for this elemental strip of this liquid film of radius r and thickness dr over this plastic circular disc is in contact, then the frictional force exists between these two is supposed to be df on the elemental liquid film in contact with plastic circular disc. So, from this here, what is the torque required? Because our task is to torque required. First, I have to write force here. What is the force here? dF is equal to, so dF equal to mu into, what is the dF value here? Mu into mg. No, here it is a liquid film, it is there. Liquid film of certain thickness is given, certain thickness is also given in the data. So, it has to rotate, with the speed v. So, that equal to v equal to r omega. Let the thickness of this film is dr. So, this force is equal to, that frictional force is nothing but the horizontal force required to move this, plastic surface over this liquid film is F equal to eta A into A into dV by dx. So, eta into A is pi r square into dV, you write dV as it is. So, V into x is thickness. So, okay, this is the force, but what we want? Torque required to spin, this liquid film over the plastic surface. D torque is equal to dF multiplied by perpendicular distance r, So, d tau is equal to integral of dF is n into pi r square into that V equal to r omega by t into r. So, this is the elementary torque on this one. So, within the radius 0 to r. So, from this here, but this V is constant or variable? It is also variable. So, pi r square is there, into r into perpendicular distance, it is r. So, this is V is constant here, I considered V as it is. Upper surface to bottom surface, V is constant. So, here therefore, it is integral of n into pi r square into 1 minute. Here I write V as r omega, but thickness, what is thickness here? This thickness, in place of r I write here dr, this is the dr perpendicular distance. So, from this integral of 0 to r into eta into pi r cubed into omega into dr by t. So, here I consider perpendicular distance as dr. So, therefore, integral of d tau is equal to eta into pi r cubed omega into dr by t. So, from this net torque on this one, in order to spin this plastic circular disc over the oil film is equal to here eta into pi omega by t is the thickness of the oil film into integral of r cubed dr, that is r power 4 by 4 is the answer. So, this torque is directly proportional to 4th power of the radius of the circular disc. So, what I consider, when plastic circular disc is placed over the oil film, in this case here the frictional force will be different. That frictional force is in the form of viscous force here. That viscous force always applies tangential to the upper surface of the liquid, So, in place of here 2 pi r, in place of this pi r square, I considered elemental area is 2 pi r into this thickness dr. In place of pi r square, I consider 2 pi r into dr. In place of V, I write r omega, and in place of here it is perpendicular distance, it is replaced as r. So, 2 pi r into dr. So, once again, here it is for circular disc, and this one experiences the viscous forces dF. This dF is equal to eta A into dV by dx. So, because here it has to rotate over the oily film. So, dF equal to eta A into dV by dx. So, eta A into this thickness is dr, this radius is r. So, A is 2 pi r into dr into, instead of V I write r omega by thickness into t, thickness is t, is the viscous force during the movement of this plastic circular disc over liquid film. for small elementary strip of thickness dr and radius r. So, in this case, the torque required to spin this circular disc over this liquid film is d tau is equal to df into perpendicular distance r. So, df equal to eta into 2 pi r into dr into, in place of it is v r omega by t into r. So, net torque on this one equal to 2 pi eta into omega by t into, here it is r cubed dr, within the limits of integration 0 to r. Therefore, torque is equal to 2 pi eta omega by t into r power 4 by 4, and that is pi eta omega r power 4 by 2t. So, therefore, this torque is directly proportional to fourth power of the radius. So, answer is T, the torque is directly proportional to fourth power of the radius of the plastic circular disc. So, while moving this plastic circular disc over liquid film, so viscous force acts on the upper layer of the one of the elementary strip of thickness dr and area, surface area in contact with this plastic circular disc is 2 pi r into dr. This length is 2 pi r, this thickness is dr. So, due to that here this thickness is dr. This is 2 pi r into this thickness is dr. So, surface area in contact with the upper surface of the plastic and circular disc is 2 pi r into dr. So, from this I calculated torque in spinning this circular disc over liquid film. Force multiplied by viscous force multiplied by, that is resistive force multiplied by perpendicular distance during spinning of this circular disc over liquid film. So, that is eta into 2 pi r into dr into r omega by t into r. From this, after calculation by doing integration within the limit 0 to r, we get torque equal to pi eta into omega into r power 4 by 2t, where t is the thickness of the liquid film, in this case. So, torque is directly proportional to fourth power of this circular disc. Okay, right. Question number 15. Let omega be the angular velocity of the earth rotation about its axis, assuming that acceleration due to gravity on earth surface has value at equator and poles. An object weight at the equator gives same reading as taken at depth d below the surface. So, for earth here, at a line of equator, at a place of angle of latitude theta, the acceleration due to gravity is equal to g pi is equal to g minus r omega square into cos square pi, where pi is the angle of latitude. So, at line of equator, its angle of latitude is 0 degree. So, therefore, g pi is equal to g minus r omega square, but it is equal to, according to given data, it is equal to the g value at certain depth. G value at certain depth is g into 1 minus d by r equal to g minus r omega square. So, from this, minus g into d by r is equal to minus r omega square, g gets cancelled. From this, what we want here? Then value of d. So, d is equal to 1 r, well, d equal to r square omega square by r square omega square by g. R square omega square by g is the answer for this question. So, answer is A for question number 15. Once again, what is the equation for acceleration due to gravity at a place on line of equator? At a place on line of equator, it is pi value is equal to 0. So, at any place of angle of latitude pi, acceleration due to gravity is g minus r omega square into cos square pi. So, according to given data, it is equated to weight is also same at certain depth d from surface of the earth, that is g into 1 minus d by r. G into 1 minus d by r is the equation for acceleration due to gravity at a place at a certain depth d from surface of the earth. So, by equating these two, we get d value as r square omega square by g is the answer for question number 15. Answer is A. Question number 16. A uniform circular ring of mass m lying at a distance root 3a from center of the sphere of mass capital M just over the sphere. When small radius of ring as well as that of sphere, the gravitational force exerted is So for ring here, the gravitational intensity, at a point which is at a distance x, the gravitational intensity at a point on the axis of the circular ring of mass m, radius r is, that is minus gmm by r square plus x square whole to the power 3 by 2 into x. So here at this point, what is the gravitational intensity due to ring? So at point O, gravitational intensity due to ring at this point is only g. What is the mass of the ring? It is small m. Mass of the ring is small m. Okay. Now a sphere is, imagine a sphere is kept at that point. Sphere can be considered as a point mass. So point mass is supposed to kept at the point, which is where the gravitational intensity due to circular ring is, here it is minus gm by r square plus x square whole to the power 3 by 2 into x. So therefore force experienced by this sphere, due to ring is F equal to gravitational intensity due to ring into mass of the sphere. Therefore that equal to minus gmm by r square plus x square whole to the power 3 by 2 into x. But what is x value? X is given as root 3a and radius is given as small a. Therefore the force experienced by this sphere, or force experienced by sphere due to ring is F is equal to, it is g magnitude I considered, gmm by r square is a square plus x square is root 3a whole square, that is 3a square whole to the power 3 by 2 into x is root 3a, that equal to gmm by 4a square. 4a square means it is 2a whole square whole to the power 3 by 2 into root 3a. So 2 gets cancelled, 2a whole cube, that is 8a cubed. That is root 3 gmm by 8 into a square. So root 3 gmm by 8 into a square is the answer for question number 16. So answer is D for question number 16. What I calculated here, what I followed here, simply I considered for a circular ring at a distance on its axis, gravitational intensity is gm by r square plus x square whole to the power 3 by 2 into x, where x is the distance from center of the ring to the point where intensity to be calculated, where r is the radius of the ring, m is the mass. Now you imagine this sphere as a point mass of mass capital M, supposed to place at the center indirectly, that is at a point which is at a distance root 3a on the axis of the circular ring. So the force experienced by this mass kept at a distance on the axis of the circular ring is, force is equal to gravitational intensity due to ring multiplied by mass kept at that point, that is minus gmm by r square plus x square whole to the power 3 by 2 into x. So from this force experienced by this one is multiplied by substituting this x value as root 3a and r value as a, then we get force experienced by the sphere due to this ring is root 3 gmm by 8 a square is the answer for question number 16. Question number 17. The velocity of the flux of the given arrangement is. So to find the velocity of flux, simply have to apply Bernoulli's theorem. So what is Bernoulli's theorem? During flow of fluid, the total energy per unit volume remains constant at any point of flow of the fluid under steady state, under steady flow. So I considered here, this is the point at top surface of the liquid and another point exactly opposite to the liquid comes out through the small hole. This is the velocity of a flux. So at point 1, what is the total energy per unit volume? So with respect to this reference line, so you have to consider the reference line which has to pass through the point where the liquid comes out through the vertical container filled with liquid like this. So reference line is to be taken horizontally and has to pass through the point where liquid comes out through the small hole. With respect to this reference level, at point 1 there is a potential energy per unit volume. What is the potential energy per unit volume? Rho g into this h. 2h plus rho g into this h is, only this is given as h, plus rho g into h, plus the velocity of the, generally for practically the velocity of the liquid in the beaker is almost all taken as 0 with when compared to the velocity of the liquid comes out to the small hole. So due to that, here it is half rho into 0 square is equal to total energy per unit volume at point 2. So at point 2, total energy per unit volume at point 1 is equal to total energy per unit volume at point 2. So total energy per unit volume at point 1 is rho g into 2h plus rho g h plus half rho 0 square equal to, at this point with respect to this reference level, potential energy is 0 plus kinetic energy is half rho v square. So from this it is 3 rho g h is equal to half rho v square, rho gets cancelled, v equal to root of 6 g h. So velocity of flux of the liquid through this small hole is root of 6 g h is the answer for question number 17. So answer is A for question number 17. It is also another important methodology for finding of velocity of flux if immiscible liquids are given with different heights. Okay, right. Next question. Question number 18. Consider two circular identical rings of each mass m and radius capital fixed on the horizontal axis in a gravity-free space. A particle of mass m held at rest at the center of the first ring and projected along the axis towards second ring. Find the minimum speed of projection so that particle reaches the center of the second ring. So in between these two rings, distance of separation is 2r, mass is same, radius same. On the axis of these two rings, coaxial axis of these two rings, a particle of mass m is projected from center of the first ring so as to reach the center of the second ring with some other velocity. So as to just reach the center of the second ring, there is some difference. So as to just reach this mass in the second center of the second ring, then it has to be projected with certain minimum velocity that we have to calculate. So at point 1, the point of projection, at this point of projection, total energy of the projected body is equal to total energy of the body which reaches finally. So your duty is to project this body from center of the first ring to the point where center of mass of these two rings are located. So this is the position of center of mass. This is the final position of the body at which it has to reach. When this body reaches the center of mass of the two rings, position of the two rings, then automatically due to force of attraction it slowly moves and reaches the center of the second ring. So our duty is to project this body from center of the first ring just to reach the center of mass of the position of these two rings. So what is the position of center of mass of the position of these two rings here? When two equal masses are separated by a distance 2r, then the position of center of mass is, so center of mass locates at capital R distance from first ring. So total energy at point of projection, equal to gravitational potential energy due to self ring, that is minus gmm by capital R, plus gravitational potential energy due to second ring at this point minus gmm by square root of, it is gmm by square root of this distance here. This distance, what is the distance here? 2r square, 2r whole square plus r square. This is the gravitational potential energy of this mass with respect to second ring, minus gmm by root of r square plus x square, plus kinetic energy half m, it is v naught square. that V naught value to be calculated. Now, when it reaches the center of mass, then final kinetic energy of the body, final energy of the body when it just reaches position 2. At position 2, the potential energy is minus gmm by square root of r square plus distance is also r square, and plus of minus for second ring gmm by root of r square plus kinetic energy is 0. So, this is the total energy of the projected body when it just reaches center of mass. At that position is the total energy. By equating total energy at position 1 and total energy at position 2. So, what is the total energy at position 1? Minus gmm by r minus of gmm by root of r square plus capital R square plus half mv naught square is equal to minus gmm by r square plus minus gmm by r square here. So, therefore, total energy at point 1 is equal to total energy at point 2 minus gmm by r plus of minus gmm by root of 2r whole square, 4r square plus r square root 5r plus half m v naught square is equal to minus gmm by r square plus 2r square, that is root 2r, into it is also there, it is into 2. So, now we want kinetic energy, half mv naught square is equal to minus gmm by r is taken as common factor into here it is 1 plus 1 by root 5 minus it is 2 is there. So, 2 is there. So, root 2 minus root 2. So, this is now from this we want V naught square. V naught square equal to mm gets cancelled, gm by r into 2 is there, 2 gm by r into 1 plus 1 by root 5 minus root 2. So, V naught is equal to root of 2 gm by r into 1 plus 1 by root 5 minus root 2 is the equation for velocity of the body at which it has to be projected from center of the first ring to just to reach the center of the second ring. What I did here, when it is projected from center of the first ring, when just reaches the center of mass of the separation of these two rings, then only automatically it will slowly attract towards second ring and reaches the center of the second ring. Okay. So, due to that here I considered law of conservation of energy at point of projection at final point of reaching of this body. So, there only for first at point of projection it has potential energy due to first ring plus potential energy due to second ring plus kinetic energy of the projected body. At center of mass position it has only potential energy due to first ring plus potential energy due to second ring, but kinetic energy becomes 0. So, after calculation we get V naught as root of 2 gm by r into 1 plus 1 by root 5 minus root 2 is the answer for question number 18. It is another standard model question. Question number 19. The L-shaped narrow tube containing liquid of density rho, it is accelerated horizontally as given. The pressure at point A is, so pressure at point A. So, pressure at point A is equal to pressure at, suppose it is point B. So, pressure at point B plus it moves with an acceleration A. So, that is rho into the acceleration of this vessel into this distance 2h. So, pressure at point B is equal to pressure, atmospheric pressure is P naught plus rho GH, rho into, that is rho naught into G into H plus rho naught into A into 2H, but A value is given as G. So, P naught plus rho naught into GH plus rho naught into G into 2H, that equal to P naught plus 3 rho naught into GH, P naught plus 3 rho naught into GH, or that equal to P naught plus 3 rho GH is the pressure at point A. So, when this vessel moves horizontally with constant acceleration A equal to small g, what the pressure at point A? Pressure at point A is equal to pressure at point B, plus pressure due to this liquid columns of vertical liquid columns of height h. So, in this case pressure at point B into rho naught into, sorry, here it is in place of this one, pressure at point B, pressure at point B plus pressure due to this horizontal liquid columns of pseudo acceleration, it is A. So, therefore, Pb is P naught plus rho naught Gh plus rho naught A into 2H. A is replaced as G. So, from this we get P naught plus 3 rho naught Gh is the equation for pressure at point A for this L-shaped narrow tube containing liquid of density rho or rho naught moving with constant horizontal acceleration A. So, answer for this question is A for question number 19. It is also another standard model based upon the previous point. Next question, 20, question number 20. A force applied by an ideal liquid stream on a container shown in the figure is proportional to. A small hole is made at the vertical wall of this container at a depth h from free surface of the liquid. We know that the velocity of a flux is v equal to root of 2gh. At that time, with what force liquid comes out to the small hole of area of cross section A? That is, this force is equal to A rho into v square. So, with what force this liquid comes out to the small hole of area of cross section A, that is A rho v square, that is equal to A into rho into, instead of v square I write 2gh. So, that is 2A rho gh. 2A rho gh is the equation for force at which liquid comes out to the small hole. What we want? Force applied by an ideal liquid stream on the container. So, action reaction pair. So, what force liquid applies on the container, that will be equal and opposite, equal in magnitude but in opposite direction. So, force exerted by liquid on the container is 2A rho gh. So, this force is directly proportional to, this force is directly proportional to h value. So, answer is B. Next question. Question number 21. A cubical block of side A and density slides over a fixed inclined plane with a constant velocity. then there is a thin film of viscous fluid of thickness T between plane and block, then coefficient of friction. Then coefficient of friction is nothing but in the form of coefficient of viscosity is given for thin film. Then what we want? That to be calculated, coefficient of viscosity. So here coefficient of viscosity eta to be calculated. So on the inclined plane, there is a thin film is placed like this of inclination theta. Over this a block of mass m is placed. So this block slides over the thin film with constant velocity v. So constant slides over this thin film with constant velocity v means net force acts on this one is 0. So if body slides down from top to bottom of the inclined plane with constant velocity, then net force acts on the body is 0. So what are the forces are acting on this? What are the forces are acting on this block here? One is mg sin theta in downward direction, and the force on this force on the liquid film in contact with the bottom surface of the block will be the viscous force. Nothing but horizontal viscous drag over the liquid film which is in contact with the bottom surface of the block. So that is the viscous force, that equal to eta A into dV by dx. So this mg sin theta to be balanced by this viscous drag by this liquid film on the lower surface of the block. So when it slides down with constant velocity, then only net force is 0. Due to that, the downward force acts on the block which slides over the liquid film is balanced by this viscous force. So due to that, I write mg sin theta is equal to eta into area of contact of the lower surface of the block in contact with the liquid film is, it is cubical block, it is, so A square into V by thickness is also A. Thickness of the film, not A, it is suppose T. Thickness of the liquid film is T, is equal to mg sin theta. So from this what we want here? Eta. Mass of the block is written in terms of density as volume into density of the material of the block into g sin theta is equal to eta into A square into V by T. So from this we want coefficient of viscosity of this film, that equal to A square gets cancelled, A rho g sin theta into T by V. So this is the equation for coefficient of viscosity of the thin film placed over inclined plane at which this block slides over this film with constant velocity. So answer is rho A gt sin theta by V is the answer for question number 21. Next question. A thin circular plate of radius A is kept at rest on the whole of the radius R in a container. Given is filled with liquid of density rho. Yes. What can be the maximum value of M so that plate does not get lifted? So here on the plate, what are the forces are acting on the plate connected to the block of mass M? At the same time, this plate is under the influence of liquid column of length h, and also it is under the influence of atmospheric pressure over upside and downside also here. So on this plate of area pi A square, that is radius is A is given. So what are the forces are acting on the plate? One is here weight of this one, it is mg is equal to tension in the string, that is T. Tension in the string is T. So first one, it is tension in the string is T. And downward force on the plate is force due to atmospheric pressure P0 into pi A square, and downward force on the plate due to this H layers of liquid column, that is rho GH into pi A square. Now on the plate in upward direction, the force due to atmospheric pressure is P0 into this area is, this radius is R, So P naught into pi r square is the force in upward direction. At the same time, force due to this liquid here, force, upward force by this liquid on the plate, that is P naught plus this length is given as. So at this point, force is P naught plus due to this layer, P naught plus rho g h into area of cross section is pi into, here it is a square minus r square. So force due to this part of the liquid, on the circular plate is P naught, P naught, P naught. So you have to consider this plate here due to this liquid here, you have to consider this P naught plus rho g h into area of cross section is pi into a square minus r square is the force in upward direction, by this liquid column just beside of this radius on the circular plate of radius small a is given. So these are the forces are acting on the plate. One is force in downward direction due to atmosphere plus force in downward direction due to H column of liquid layer. Tension in the string is in upward direction, and force due to atmosphere in the area of cross section pi r square in upward direction, and force due to this liquid column on both sides in upward direction is P naught plus rho g h into area of cross section of this part only. Is pi into a square minus r square. Now we balance the equation, that is in upward direction P naught, in downward direction P naught plus rho g h into pi a square, okay, plus in downward direction no other force, that equal to in upward direction T plus P naught into pi r square plus P naught plus rho g h into pi into a square minus r square. So from this we want tension. T is equal to P naught plus rho g h into pi a square minus of P naught into pi r square minus of P naught into pi a square minus of rho g h into pi a square minus of this one rho g h into, so P naught into pi a square minus of here it is rho g h into pi a square. Now minus of P naught into r square is taken to that side plus P naught into pi r square. Next one, this is taken, rho g h into pi r square is taken to that side, rho g h into pi r square. So this is the tension. So here P naught is there. So P naught into pi a square is there. Rho g h into pi a square. Okay. So P naught into pi a square gets cancelled. Rho g h into pi a square gets cancelled. Next one, P naught into pi a square gets cancelled. Then we get T equal to rho g h into pi r square. But this tension is balanced by mg equal to rho g h into pi r square. So from this, mass of this body was balanced is rho h into pi r square is the answer for the mass of the body suspended. In order to just mass of the body suspended from the pulley, just to lift up this plate is m equal to p rho h into pi r square is the answer. Rho h into pi r square is the answer for question number 22. So on this plate, what are the forces are acting? In downward direction, these are the two forces. In upward direction, here this force along with the tension. So by equating these two forces and T is written as mg, then the mass connected to this pulley and to the plate by means of this string, so that the plate just get just gets lifted. That is equal to rho h into pi r square. Rho h into pi r square is the answer for question number 22. It is another standard model question regarding JEE mains and advanced level examination. Next, question number 23. A water jet strikes on a stationary inclined flat smooth surface. After hitting the surface, flow distributes into two parts as given. Then find the ratio of Q1 and Q2, where Q1, Q2 are the rate of flows of water after striking the surface. So here at what force this water jet strikes? At what force it strikes? Water jet strikes the inclined plane. It is F is equal to V into dm by dt. V into dm by dt, that equal to V into dm value. So it is d by dt of mass is volume into density. So that equal to V rho into dV by dt. But rate of flow dV by dt is represented as Q according to given data. So V rho into Q. So with what force this water jet strikes the smooth inclined plane? V rho into Q, where Q is the rate of flow of, let Q is the rate of flow of water at which it strikes the smooth inclined plane. Then this jet splits into two parts. One moves up with the rate of flow Q1 with speed V, another moves down with rate of flow Q2 and velocity V. So in this direction, here the force is Q1 V into rho. In this direction, force exerted by water jet is Q2 into V into rho. But the difference of these two will be the component of this force. So on inclined plane, in this direction it is Q into V1 Q into, see here, Q1 into V rho. In downward direction it is Q2 into V rho. But here on inclined plane, the component of this force is Q V rho. This angle is given as theta cos theta. The difference of these two forces of the two parts of the jet strikes the smooth inclined plane is balanced by the component of this force at which it strikes in this direction. So actually it strikes along this direction with force V rho Q, and the component of this force along the inclined plane is, suppose it is theta. It is theta, this one is also theta. So due to that component is, it is F cos theta. That is equal to V rho Q cos theta. So difference of these two forces will be equal to V rho Q cos theta. So therefore Q1 V rho minus Q2 V rho is equal to Q V rho cos theta. So from this here, V rho gets cancelled. Q1 minus Q2 equal to Q cos theta, equation 1. But initially it strikes with rate of flow Q, splits as Q1 and Q2. Therefore, Q value is the sum of the individual rate of flows here, Q1 plus Q2, equation 1. It is equation 2. So Q1 plus Q2 is equal to Q. So by adding these two, 2Q1 is equal to Q into 1 plus cos theta. So Q1 equal to Q by 2 into 1 plus cos theta. Equation 3. By substituting equation 3 in either 1 or 2, in 1 or 2 here, then we get Q2 value as Q by 2 into 1 minus cos theta, equation 4. So by dividing 3 with 4, what we want, see here, what we want, the ratio of the Q1 to Q2. So Q1 by dividing 3 with 4, 3 divided by 4, then we get Q1 by Q2 is equal to 1 minus cos theta by 1 minus cos theta by 1 plus cos theta. So Q1 1 plus cos theta. 1 plus cos theta by 1 minus cos theta is the answer. So once again, what I considered here, the force at which jet strikes the smooth inclined plane is V rho into Q1 is the key point of this problem. Now the component of this force along the smooth inclined plane upward direction is V rho Q cos theta. This is the resultant of these two forces of the two parts of the stream. One moves in upward direction and the moves in downward direction. Resultant of these two will be equal to V rho Q cos theta. But here with what rate of flow it strikes Q, that will be split as Q1 and Q2. So I write Q equal to Q1 plus Q2, equation 1, this one as equation 2. So by solving 1 and 2, we get Q1 value as Q by 2 into 1 plus cos theta, Q2 value as Q by 2 into 1 minus cos theta. By dividing 3 with 4, we get Q1 by Q2 equal to 1 plus cos theta by 1 minus cos theta. So answer is B is the answer for question number 23. The another standard model question it is. Question number 24. An open railroad car of mass m moves with initial velocity v0 on straight horizontal road or horizontal frictionless track. It is suddenly starts raining at the time t equal to 0. The raindrops are falling vertically. With velocity v, and add mass of mu k's per second. Determine the velocity of the car. So after t seconds, so what is the mass of the rainwater? Mass of the rainwater is m dash is equal to mu k's per second after t seconds mu into t. So this is the mass of the rainwater. So what is the total mass of the tank after t seconds? Total mass of the tank after t seconds equal to m plus m dash, that equal to m plus mu t. Now even though rainwater is falling into the tank and fills up slowly up to certain level, but it creates some no external force acts on the system. So due to that, external force is 0. When we consider external force acts on the system is 0, so linear momentum is conserved. Before raining at t equal to 0, the momentum of this tanker is m into v0. After t seconds for raining continuously with constant rate of fall as mu k's per second, then it is m dash into v dash. So from this what we want? What is the velocity of the truck after t seconds? V dash is equal to m v0 by, what is m dash here? M plus mu t. M plus mu t is the answer for velocity of the truck after t seconds. So I considered a simple process for this simple question. Actually it is a problem related to variable mass. Now we have to integrate by considering elementary mass of that rainwater. But here for such simple questions, even though if you consider law of conservation of linear momentum, the answer will be approximately tried. For that reason I opted in this model. So due to that, here I considered external force acts on the system is 0. Due to that I consider law of conservation of linear momentum. So total momentum of this container before and after raining for t seconds. So I calculated mass of the tanker along with rainwater is m plus m dash is mu t. So velocity of the tanker after t seconds of collection of rainwater is m v0 by m plus mu t. So m v0 by m plus mu t is the answer for question number 24. Question number 25. A block of mass m is pulled along the horizontal surface by applying a force F at an angle theta with horizontal. So what are the forces acting on the block? If the block travels with uniform velocity and has displacement d, coefficient of friction is mu, then what is the work done by applied force? Work done by applied force here. First you have to calculate force here. So what is the force here? Force acts on the block at an angle theta with horizontal. So component of the force along this direction is F cos theta, and normal reaction by this one is N. The frictional force is Fs, that is F, limiting friction Fs, and weight of this one is mg. So these are the forces are acting on the body. So in this case here, it moves with constant velocity. So, f cos theta is equal to limiting friction Fs. So, Fs is equal to mu s into normal reaction equal to f cos theta. So, what is normal reaction? The component of force along horizontal direction is f cos theta, along normal direction is f sin theta. So, from this along this direction n plus f sin theta is equal to mg. So, n is equal to mg minus f sin theta. Equation 1, it is equation 2. You substitute 1 in 2. Then f cos theta is equal to here it is mu s into n, mu into normal reaction is written as mg minus f sin theta. Mg minus f sin theta is equal to f cos theta. So, you take f cos theta, f and f towards this side, it is cos theta plus mu sin theta is equal to mu mg. So, from this f equal to mu mg by cos theta plus mu sin theta. This is the force applied. What we want? Here, if it is dragged, the body is dragged along the horizontal surface through a distance d. So, work done is equal to force along horizontal direction is f cos theta into displacement, that equal to mu mg cos theta into displacement by, here it is cos theta plus mu sin theta is the amount of work done in moving this block through a displacement d on the horizontal surface when it is acted upon by a force f at an angle theta with the horizontal. It is mu mg cos theta into d by cos theta plus mu sin theta is the answer for this question. So, answer is mu mg d cos theta by sin cos theta plus mu sin theta. Answer is B for question number 25. Next question. A projectile is fired with velocity u making an angle theta with horizontal. What is the angular momentum of the projectile at the highest point about starting point here? For projectile at highest point, all of you know, when it is projected with velocity u at an angle of projection theta, so about this point of projection we have to calculate angular momentum. But at highest point of its path of its motion here, the velocity is u cos theta. So, along this direction momentum is mu cos theta. So, about this point O, the perpendicular distance r is, about this point O, the perpendicular distance r equal to h. So, what is the angular momentum? Angular momentum is equal to r bar cross p bar. Magnitude of angular momentum equal to rp sin theta. So, for this one angle is 90 degree. So, due to that r into p momentum, r is h into momentum is mu cos theta. So, angular momentum L equal to r into mu cos theta. R is h into mu cos theta. H value is u square sin square theta by 2g into mu cos theta. So, from this we get mu cubed sin square theta cos theta by 2g is the angular momentum of the projectile when it is at highest position with respect to point of projection is mu cubed sin square theta cos theta by 2g is the answer for question number 26. Mu cubed sin square theta cos theta by 2g is the answer for question number 26. So, what I considered? I considered linear momentum of the projectile at highest point of its path, that is mu cos theta. With respect to this point of projection, this momentum is at a perpendicular distance h, that equal to maximum height reached by the projectile. So, r is h. So, what is the angular momentum? R bar cross p bar, that is r into p into sin theta. Theta is 90 degree here. So, r into p. R value is h into p value is mu sin theta. So, it is h value is maximum height reached by it, that is u square sin square theta by 2g into mu cos theta. From this angular momentum of this projectile when it is at highest point of its path with respect to its point of projection is mu cubed sin square theta into cos theta by 2g. Angular momentum is always to be calculated with respect to a particular point. That point is the starting point here according to given data. So, answer is mu cubed sin square theta cos theta by 2g. Question number 27. A balloon of total mass m and fixed size starts coming down with an acceleration f. F is less than g. So, a balloon of some mass I do not know moves down with an acceleration f. So, what is the apparent weight of the balloon? Here it is apparent weight of the balloon equal to m into g minus a is f. If some mass is removed, the fraction of the total mass of the balloon which must be dropped from it, the fraction of the total mass of the balloon which must be dropped from it so that it starts going up. If some mass is removed, some mass is removed means here it is m minus x. If some x mass is removed from the balloon so that it moves up with same acceleration f, then apparent weight is R2 is equal to m minus x into g plus a. So, if some mass is removed, at that time it just take its direction reversely. Just instead of moving down, it just reverses its direction. At that point of reversing its direction, the apparent weights are equal. So, apparent weight while moving down is R1 is equal to apparent weight just reverses its direction while moving towards upward direction. At that point, I equated this apparent weights of the balloon. So, in first case it is m into g minus f. In second case, if some mass is removed, then m minus x into when it moves up, the apparent weight is g plus f. So, by multiplying this one, mg minus mf is equal to mg plus mf minus gx plus xf. So, mg gets cancelled. This mf is taken to this side, 2mf is equal to this x is taken as common factor. This is taken as common factor x into g plus f. So, from this x by m is equal to 2f by g plus f. So, this is the fraction of mass to be removed from the balloon so that it has to move up with an acceleration is equal to f. So, this is the fraction of mass. Fraction of mass m is to be removed from the balloon so that it has to move up with same acceleration f. That is 2f by g plus f is the answer. 2f by g plus f is the answer for question number 27. Another basic question it is. Question number 28. Both the blocks shown here are of mass m and are moving with constant velocity in a direction shown in the resistive media, which exerts equal constant force. When this block moves like this is the resistive force. When this block moves down, this is the resistive force. But this resistive force is constant in both directions. Okay, opposite to the direction to the velocity of this block. The tension in the string connecting both of them will be. Let the tension in the string is suppose T. The weight of this block is mg. Here also it is T. So, here it moves with an acceleration a. Suppose here this block moves down with an acceleration a, then this block moves horizontally on the surface with acceleration a because masses are same. Now, according to free body diagram of this block, what is the force acts on this block? T. So, T equal to ma. So, according to free body diagram of this block, the force acts on this block is mg in downward direction, tension in upward direction. So, net force is mg minus T equal to ma. Equation 2. Equation 1. By substituting T equal to ma, then we get mg minus ma equal to ma. So, 2ma is equal to mg. So, from this a equal to it is g by 2. So, what is the acceleration of this block B? G by 2. Acceleration of the block A is also g by 2. So, both blocks moves with the acceleration g by 2 in the presence of constant retarding force by this medium. So, that is the meaning of the word. By applying, even though constant retarding force acts on this one, but it is opposite to the direction of the motion of these two blocks, then these two blocks moves with acceleration a equal to g by 2. So, for question number 28, answer is g by 2. Then the tension in the string is T equal to m into a. Therefore, m into instead of a, I write g by 2. So, answer tension in the string is mg by 2 is the answer for question number 28. Question number 29. Figure shows 5 k's ladder hanging from the string that is connected with ceiling and is having spring balance connected in between them. A man of mass 25 kg is climbing up the ladder at an acceleration 1 meter per second square. Assuming that the spring balance and the string to be massless, the reading of the spring balance is. So, in this case here, this is the spring balance connected to a ladder. This ladder weight is 5g, and a man on the ladder, mass is 25 kg, moves up with an acceleration a equal to 1 meter per second square. So, what is the reading in the spring balance? So, first we consider for ladder only. So, what is the norm when man moves up? The normal reaction by the ladder and the man in upward direction. When we pushes the ladder in downward direction, ladder pushes up the man in upward direction. So, on ladder here, on the man, normal reaction is in upward direction. Weight of the man is in downward direction. So, net acceleration by the man on the ladder is a. So, what is the equivalent equation? N minus mg is equal to ma. N minus mg equal to ma. That is the normal reaction exerted by ladder on the man and man on ladder. Okay, normal reaction exerted by ladder on man or man and ladder in opposite direction. So, therefore, N is equal to ma plus mg, that is equal to m into g plus a. M value is 25, g value 10 plus 1, that is 11 into 25. 11 into 25 is 275. 275 Newton is the normal reaction exerted by man and ladder or ladder and man. So, normal reaction exerted by man and ladder in downward direction. At the same time, weight of the ladder is 5g. So, what is the reading in the spring balance is equal to normal reaction plus weight of the ladder, that is equal to 275 plus weight of the ladder is 5g, that is 50. That is 375 Newton. 375 Newton is the reactional force that is reading in the spring balance in terms of Newton, but in terms of kilogram we want. So, reading of the spring balance in terms of kilogram, that is 375 by 10, that equal to 37.5. 37.5 kg is the reading in the spring balance. So, first I calculated the normal reaction exerted by man on the ladder or normal reaction exerted by ladder on the man, that is 275 Newton. In case of spring balance, that normal reaction to be in downward direction, that is reaction by man on the ladder. At the same time, weight of the ladder acts in vertically downward direction, that is 50 Newton. So, both to be added, that will give reading of the spring balance as 325 Newton. So, it is 325 by 10. So, 32.5 kilogram is the reading shown by spring balance. So, 32.5 is the answer for question number 29. So, it is 325 Newton is the answer. So, that is 32.5 kg is the reading shown by 32.5 kg is the answer for question number 29. Question number 30. In the figure shown, the pulley and string are frictionless and massless. Then the relation between the accelerations of mass m and capital M is. First, you have to identify the tensions in the corresponding strings connected to the blocks. Here this weight is mg. So, due to the tension in the string is T. Here also tension is T. Here also tension is T. Here also tension is T. So, what is the total upward force? Total upward force on the block of mass capital M, that is 3T. What is the force on the block of mass m in the form of tension? It is T. So, here I use power equation, power method. What is power? The algebraic sum of T bar dot V bar equal to 0 in case of pulleys connected to different number of blocks. So, this is called power method. Indirectly, the algebraic sum of powers transferred by all these blocks is equal to 0. By differentiating of this one, we get T bar dot A bar equal to 0. So how many blocks are there? 2 blocks. So therefore T1 bar dot A1 bar plus T2 bar dot A2 bar equal to 0. So for this block tension is T. T into, let it moves down with an acceleration A. T into acceleration of the block of mass M into T1 bar dot A bar cos theta. Angle between these two is cos 180 plus T2 bar is 3T. Then this block moves up with an acceleration AM, but angle is in same direction 3T and acceleration of this bigger block is in same direction. So it is cos 0, that equal to 0. Cos 180 is minus 1. So T into acceleration of small m equal to small m block equal to 3T into acceleration of the bigger block. So Tt gets cancelled. Acceleration of the smaller block equal to 3 times that of acceleration of the bigger block. So acceleration of the smaller block is equal to 3 times that of acceleration of the bigger block is the answer for question number 30. So it is another standard model regarding the finding of relation between accelerations and velocities. So you have to use power method here. So what is power method? The algebraic sum of powers connected to blocks, power of the blocks connected to the pulleys by means of strings is 0. It can be equated, it can be applicable in this form also, sigma T bar dot A bar equal to 0. So here this block supposed to move on with an acceleration A with the corresponding tension T, then T bar dot A bar is TA cos 180 plus this block moves up with the support of this tension 3T with an acceleration AM and angle is cos 0. Therefore 3T into acceleration of this block of mass M is there and its acceleration is AM into cos 0 equated to 0. Here 2 blocks are there. Whatever may be the number of pulleys are there, how many blocks you have to consider? How many blocks are in the connection, that you have to consider. Irrespective of the number of pulleys connected in this such type of model problem, you have to consider only how many number of blocks are there. For corresponding block, the corresponding tension is to be identified. So on that basis, you can identify the relation between acceleration of this smaller block and acceleration of this bigger block. Okay. So for question number 30, answer is A. Question number 31. On horizontal surface of the two blocks A and B of mass 2 kg and 4 kg are arranged with light pulley as shown in the figure. So these are on the horizontal smooth surface. Now force applied here, it is F equal to 10T. Force applied F equal to 10T. But here it is on horizontal surface, so it starts motion after some time interval because the limiting friction is mu mg. What is the mu value? 0.5 into mass of this block is, what is the mass of this block? 2 kg into g value 10. So that equal to, here it is 10 Newton. The tension in the string is T. At the same time second block also begins to move after some time interval. So what is the frictional force it is? Here it is frictional force is equal to 0.5 into 4 into 10, that equal to 20 Newton. The tension is T. So here when you apply a force F equal to 10T on pulley, center of the pulley, here the force on the first block is T, but this must be equated to limiting friction. It must be equated to limiting friction in this case. So T equal to, what is T here? T plus T, 2T equal to 10T. So 10T or 20T, here it is 20T, sorry, it is 20T. From this T equal to 10T. This 10T is equated to limiting friction in first block. So 10T1 is equal to 10 Newton. So from this T1 is equal to 1 second. So after 1 second it begins to move with certain acceleration. Next, what is T here? 10T is equal to 20 Newton. So T2 is equal to 2 seconds. So second block begins its motion after 2 seconds. So what we want? The difference of these two time interval. So T2 minus T1 is equal to 2 minus 1. That equal to 1 second is the answer. 1 second is the answer for question number 31. Easy question it is. Question number 32. In the figure shown, all surfaces are smooth, then the relation between V1 and V2. So as this rod continues in contact with this wedge, which is placed on smooth surface. As this rod continues in contact with the wedge placed on smooth horizontal surface until this rod comes to the bottom of this wedge. So, when this rod comes to bottom of this edge, this rod moves down through a displacement, vertical displacement y. At the same time here, this bottom of this wedge displaces through a position, displaces through a distance x. As this rod comes down from this position to bottom of the wedge placed on smooth horizontal surface, then this wedge slips towards right side with velocity, here it is v1. So, indirectly here this wedge moves through a displacement, horizontal displacement x in the same time interval. At the same time interval, this rod moves down vertically through a displacement y, and this angle of inclination is theta. So, from this you write tan theta equation. Tan theta is equal to y by x. So, y equal to x tan theta. By differentiating this one with respect to time, we get dy by dt equal to dx by dt into tan theta. Theta is constant here. So, therefore, dy by dt is the displacement of the rod with respect to time, nothing but velocity of the rod, that is v2, equal to dx by dy by dt is v2. What is dx by dt? It is the displacement of the wedge towards horizontal direction, that is v1 is given in the data. So, v1 into tan theta. So, therefore, v2 is equal to v1 tan theta is the answer for question number 32. So, v2 equal to v1 tan theta. So, it is also one of the standard simple basic question it is. Okay. So, these are the different questions I explained under this module of mechanical properties of solids, mechanical properties of liquids, gravitation and Newton's laws of motion. So, this module consists some of the most different and difficult model level questions. So, you have to go through those models for having better idea. Okay. Thank you all.